I'm Subhash Talluri. I'm a solutions architect focused on ML, been with AWS over 5 years. So for today's session, I'll be focusing on Amazon Bedrock Core Runtime. But before that, we will go over what is Amazon Bedrock Core and how the runtime fits into Bedrock AgentCore service, right? So let's start there. Bedrock AgentCore and a deep dive of the runtime. So we have 30 minutes, plenty to cover. So let's get started. Bedrock AgentCore. To simply explain this, right? In 23, we were using language models out of the box. They were, by definition, they are stateless, and they might have access to some tools. Tools could be APIs, some other calls, web search, etc. So now, to make these language models stateful, you will need some constructs like memory, prompts, guardrails, observability, evaluation. When you put all of this together under a framework is what you get the agent framework. So LangGraph, the way it is managed, it manages memory in certain way. It's a low-level orchestration framework. The prompt management or observability and evaluation that LangGraph provides is one thing versus how Crew AI or Llama Index might approach it. And same is the case with Strand's Agent SDK. So by configuring all these with your language model and tools inside this framework, you are now making it more stateful, right? Now, your framework has to run somewhere. You can either deploy it in a container, run on-prem, or Dockerize it, run on the cloud, but you need some serving infrastructure. So that's where the agent deployment comes in, and this is what Bedrock Agent Core Runtime provides. So technically, a Bedrock Agent Core comes with the runtime, memory, identity, tools, gateway, and observability. So for our session today, we are going to focus on runtime, deep dive into it. And tomorrow's session, we will be handling some of the others. But technically, again, to recap, runtime is the infrastructure that we provide. How do you handle session states, etc. Memory is a different, runtime is tightly coupled with the other service capabilities with the long-term, short-term memory, identity, particularly the tools that you need to access. Today you might have tens of tools. What if you have hundreds or thousands of tools? How do you manage them at scale? And that gives you the gateway as well, being able to manage all of them through a single interface. And obviously observability, because you want to know constantly on how your agents are performing, how your requests are being served, where are the bottlenecks, etc. So this is primarily targeting DIY, integration with OSS open source frameworks and Strand agents, and obviously built-in support for protocols like MCP and A2A. So if we put this together, right, where do all of these fit in from your application perspective? So AgentCore Runtime will allow you to use any frameworks, Strands, LangGraph, Crew, etc. It's going to manage all those agent instructions, local tools, and context. You'll be able to use any model of your choice and run this behind the runtime infrastructure. The other concepts around gateway, browser, code interpreter, identity, and memory, they are tightly coupled, but each of it will bring its own merit in terms of managing your end-to-end agentic pipeline, efficiently. The idea behind AgentCore is to get you to develop production-ready agents at any scale using any framework and any model. So we want to give you the full flexibility of doing it. So let's get into a lot of low-level details, right? Rest of the session, next 25 minutes, I'm going to be talking about the flexibility of frameworks, how we approach LangGraph particularly. I believe that was one of the questions. What we mean by true session isolation, how that works, the built-in identity and authentication that is tightly coupled with runtime, the multimodal capabilities with the payload size, and the real-time and long-running workloads, because that is going to affect costs. And we will also dive into how that initialization happens. How do you handle long-running asynchronous workloads that up to 8 hours or beyond 8 hours, if you in the order of days. What are the workarounds to be able to run your runtime in the backend? So we're going to cover all of this. But let's start with, let's take the example of a use case to put everything into perspective, right? Let's assume you're creating a multi-agent customer support system. So you have your user interface, authentication, the application layer with the front end, and then you have your agent layer. In this particular case, let's assume you have that supervisor and about 4 sub-agents. Order management, product recommendation, troubleshooting, and personalization. And each of it has access to a data layer with a set of tools and APIs to be able to go fetch and deliver responses. Let's assume this is the case, right? Now, how do you today build multi-agent system from scratch? So, different agents, different frameworks, things could get complicated really easily. So when building from scratch with agents, this is how we were doing it. There are multiple ways of building it on AWS, and this is actually one of the official guidance before AgentCore was released. We have a front-end web app, a content delivery network that routes these requests. You have to manage user auth and how it connects to agent permissions and tools. You have to protect from DDoS attack and malicious traffic. You need that router logic that goes from API gateway to Lambda to an Amplify front end to an agent, right? So that's on the left. On the right, we have all these different agents to host and manage, might be built in different frameworks. Also have to manage all your tools. And this is real, right? And maybe not as complex as some of what our customers do. It can get even more complicated. But this is what we are trying to simplify with AgentCore Runtime. So you can simplify all of this. User authentication remains the same, but let's say you have your client application in your in a customer account. It has connections to all of the AgentCore capabilities. It's pretty simple to think about how runtime can simplify this process, because there's no need to manage infrastructure. By definition, sessions are isolated, right? So so in this case here, part of AgentCore services, you have all your agents, tools, identity, all managed part of AgentCore service with the runtime. So how do we get started, right? So the easiest way is AgentCore Python SDK. It's purpose built, simple to get started. You can do you can do whatever you want with the app dot entry point, as long as you decorate your main function. Now behind the scenes, it is running a server exposing port 8080 where you get your invocations from, and you can do whatever you want inside your main handler. So this is where all your agent logic will be baked in. And using this, you can either respond in an asynchronous way or in streaming chunks. So you keep all your agent logic. There is no friction from moving from one thing to the other. If you have your agents built in LangGraph today, that agent logic remains the same. You just have to add a few lines of Bedrock AgentCore, and you're good to go. There is no infrastructure to manage, such no servers, containers, or any type of scaling related work. All that is taken care of for you. So that's through the AgentCore Python SDK. Now, the SDK also goes alongside with a starter toolkit. So you can do this in 2 ways. If you're running on Jupyter Notebook or IDE, you can use Python constructs. You can do that on the left here. All you have to do is import the runtime class, which is what I'm showing here. And there is also the CLI, right? Now there are really three main steps. There is configure. When you can, so when you do configuring behind the scenes, either through runtime.config with the Python or through CLI with the AgentCore configure. Behind the scenes, it sets up ECR repository, your permissions. It will create an execution role. Any auth specific details, it could be either IAM or AgentCore identity based. So with CLI, it will create your local YAML file, saves all this information that you can take a look and edit. It creates a Docker file that you have access to, so you can edit that as well. It picks up the entry point, all of your dependencies, such as your requirements.txt, and you're able to, with that, configure. The second step is launch. So this deploys the AgentCore runtime. So we are looking at minutes to launch something like this. Of course, it depends on Docker size. A 500 MB to less than a GB of container size, you can launch and be ready for invocation within a minute. So you deploy to AgentCore runtime. And then finally, you have to do invoke with some payload. So payload or tools, whatever is in your JSON. So these are the three main steps, right? So from basically from customer feedback, we learned that there is a balance between how customers use with CLI versus Python. So we have been doing equal investment in both. So now runtime also comes with a nice console, right? Here, the whole agent core. Whatever you do on the CLI or through the API, you will see that in the console as well. You can see all of your agents within the agent view. You can also look at details, connect to observability, sample code to invoke the endpoints available, the MCP servers, tools, etc. So they are all available through the console. So let's look at some key concepts, right? The first one being the runtime Boto 3 API. So we know our clients, our clients are typically customers are smarter than us. So you want access to all the low level APIs. So in here, we are showing Boto 3 with, there are actually 50 plus APIs, and you could technically recreate your own CLI. And it's not just Python or Boto 3, right? There is also other language support as well. But the main APIs for runtime are create agent that creates the ARN, etc. This is the update agent. You can do all your CRUD operations and invoke the endpoint. All the control plane actions are on the left via a Bedrock AgentCore control. The right is invoke agents. Okay, so these are only runtime APIs, right? I'm only talking about runtime APIs right now. There are more APIs that are natively supported. So now let's step through versions and endpoints, right? Say you start with create agent API. This will give you an ARN, update the version to V1. Then you create agent endpoint. This is simplified in the CLI. It associates the endpoint so you can hit with your invocations. Now, if you have an update to either the role, the ECR repository, or lines of code that result in Docker container change, so then there will be a new version, right? That's the update agent and API. And that gives the new ARN for prod and associate with your agent with version 2 to hit with invocation. Now, the thing about this is this process is true for not just agents. You can also manage your MCP servers wherever you need these endpoints. Okay, so now that brings us to the next one being containers. Now, some of our uh, let's say in your case, you may not want to go through a standard process of auto-generating Docker containers. You might want to use your own containers that are already working. So you might just want to migrate over. The only API contract to follow in these two methods is the get method with /ping for health checks, and /invocations is where the application logic is. So anything to do with your main entry point handler gets associated with the invocations endpoint, and you can then route to any other methods from there. So this works with Docker, Podman, Finch, whichever you're using. And if you don't already have Docker installed locally, you can have your own, maybe you have your own CI/CD with Jenkins or code build. So instead of building locally, you can just build and push it to ECR repository. You're not limited because you're not able to, you don't have a Docker locally. You can still do it end to end, although local testing is encouraged, but it won't block you, right? So you can deploy to ECR and you can be up and running in just a couple of minutes. Cold start is sub-second. A sticky session in a back-to-back invoke is a couple of milliseconds. So you'll have a nice time testing even if you're doing things remotely. If you're blocked in doing any type of local testing with your Docker containers. Um, so let's see.
Meantime, team, please feel free to ask questions if you have any.
Yeah.
Sorry, Subhash, continue.
And here I give the example of one second. Yeah, this is the example of fast API, right? You can use Starlet, Express, etc. The only API contract we saw is those two methods, right? /ping /invocations. This is what you're looking at here is in a typical project, how it will look like with fast API. You have your main entry point, agent.py, the Docker file you create or it gets created for you, the requirements.txt that gets picked up by your environment manager. So you do this and you run your server, right? As simple as that. Now, but probably this is one of the important topic, true session isolation and what it means, right? So say you have a session ID, agent runtime is up and ready for invocations. You pass in your payload along with session ID, right? That session ID brings up a completely isolated micro VM behind the scenes. So that micro VM does not share compute memory or file systems with any other sessions that are running, either from the same customer or different customers. So it's completely physically isolated. So with with our offerings or with other offerings, or if you are building this on your own, then multiple sessions might execute on the same micro VM. So there can be some overlaps like temp files that are not cleaned up, or maybe just local files, local states, and other objects that could be accessed across sessions. So that problem is completely solved with true session isolation. The trade-off is performance versus isolation. We try to balance both. So you still get sub-second cold start with session isolation. So what it does is our objects, any in-memory resources, state of an agent in an agent object that's saved within the session, you can talk to it as though it's the same continuing session, right? So this is where AgentCore memory actually comes in, which we will talk about tomorrow. And that's really the differentiator for AgentCore. It's not just for information privacy, but for any applications, session isolation is going to be required. And we provide a balance of both, so that you can handle for any scenarios as you develop your agents. So that brings us to what's the life cycle of the session, right? You have your AgentCore runtime session launched and ready to accept invocation. You have a client on the right side, it's going to do invokes. So there are some limits associated. So by default for asynchronous response, waiting for the agent to finish and come back with a response, that will be um, that timeout will be about 15 minutes. Actually, this should be 15. Um, if you are streaming back a response, the timeout will be 60 minutes. So say you have a session ID and a payload that's hitting that session. You can go up to 500 active sessions per count, and that is adjustable if you need more. If there is no activity and no continuous invokes, then in 5 minutes, the session gets suspended. So the CPU cycles are cut down. AgentCore runtime is suspended in memory, but it could be restarted quickly, and it retains all the context you had in terms of local file state systems, etc. So you can continue as though the session has not terminated. You can quickly bring it up for a session that is suspended due to inactivity for 5 minutes. Now, if there is no activity for 15 minutes, the session times out, execution environment is terminated. Now, the most important one is the max session duration. It's 8 hours, and this is one of the key, uh, uh, you know, uh, capability of AgentCore runtime. It's 8 hours. You can maintain some really long uh, session activities. Now, obviously, this is not 8 hours is still not going to be a limiter. You can run it for days. You just have to smartly offload your session data, agent core memory, and then reinstate that session with this info that is stored offline. So as long as you can do that, you're not only like saving on costs, but also you can reinitiate those sessions for longer times, more than 8 hours. So that's the life cycle. The next one is for any type of async and long running jobs. So this is also where AgentCore runtime is pretty unique. So say you have a hierarchical agentic system, you have a chat application, you want to respond to the customer immediately. At this point, the work is being done in the background, right? While the container is idling. So in this case, with Python SDK and this async task, it could be a long tool call or a set of sub-agents that you need to invoke. In the background, it's creating healthy busy status. Remember the two pings, the two important methods, slash pings, slash invocations. So you use that slash pings to send busy status. So then the AgentCore runtime knows that we should not terminate your session. And you can force this status, add your app.ping decorator. It's a custom ping, and you're good to go for as long as it's needed. There are going to be some best practices that will evolve as our customers put these agents into production. So that's on async and long running jobs. Now,
Hey, Subhash, a quick check on time.
yes.
How many
Um,
slides?
I think I just have a few more. I'll be on time.
Okay,
So
thanks.
right after this, I'm going to go into some pricing details. So the next important one is going to be MCP servers or on AgentCore runtime. And you can host your MCP servers on the runtime that connects to your local tools or remote tools. A few changes to take note are, you know, in a Python SDK or fast MCP, there's a default behavior, right? It's available at port 8080. And I think you have to constantly watch for your MCP spec because that's always evolving. It's you have to go via OAuth, not IAM authentication. And the only mode of operation supported is stateless streamable HTTP. So what you see on the right is an example of MCP server that's hosted on the runtime. You have these, resources, prompts, and tools. This is just an MCP inspector running on the runtime, just to give you a feel for, um, you know, how it works. Then hosting an MCP server behind this runtime. And there's also the observability. So if you go into CloudWatch, there is a dedicated GenAI observability under which you can go to the runtime section to view all observability metrics. So again, this is observability for runtime. Um, uh, there's a lot more detail into memory evaluation and all of the other features that we'll talk about tomorrow. So that's in a which I think we covered a lot. Probably requires typically a 1-hour session to go over it one by one and go through the code as well. But I want to take a moment just also address one question, right? I think we had beforehand, and this is about LangGraph, right? If you think about AgentCore, it's production runtime with some services on memory, identity tools, etc. It's delivered as a Python SDK with invoke over the Bedrock Agent Runtime API. Then you have Strands, which is code first agent with a tiny API that scales from single to multi-agent, or used in, it's used for a model-driven approach to having an agent framework. Then there's the LangGraph, which is the low-level orchestration. It provides those stateful graphs, nodes, read-writes with shared state, deterministic branching, etc. Right? So if you are looking at integration patterns, there are two clean integration patterns. One is where LangGraph orchestrates, AgentCore becomes your node, and Strands is a skills plugin. So that's one way of doing it. The other pattern is to, the other pattern will be to actually have the AgentCore as the primary orchestrator, and you'll be working through Strands API. And within that, you'll have some sub-agents that will be defined through LangGraph. So
Hey,
those are the two
Subhash.
patterns that you can address.
Subhash, there is one question from Siri that is the max session of 8 hours duration configurable?
Uh, up until 8 hours, yes. So there are the limits that you see here. Actually, you know what? Let me go to a different slide. It actually gives you the service quotas. Okay, so on the resource allocation limits, these are all adjustable. So whereas on the invocation limits, they are not adjustable, but you have a workaround in terms of sending that busy pings to the runtime so it can keep it active. Again, same with lifetime sessions, lifecycle parameters, they're also not adjustable, but you can work around it. So the max duration is going to be 8 hours. Okay, I hope that addresses the question. The other two things I have for today is one is on pricing. Pricing is primarily consumption based for CPU and memory. And you're only charged for the actual CPU and memory resources consumed during execution. That's measured per second. And if you look at an example, right, if you have a real-time customer support agent, a lot of your cost is going to come from foundation model inferencing. Runtime is probably only going to be 5% of it. But if it is compute heavy, such as you have your data analysis agent processing these large data sets, then you're in foundation model inferencing is about half of it, and your runtime AgentCore is going to be half of the cost. So it really going to depend on whether your job is compute light or compute heavy. Okay, so that concludes the session for today. Uh, I know we
Thank you.
talked a lot, but happy to do a follow-up to dive deep into each of these items.